So welcome back to this webinar on heat and mass transfer. So today we will be solving some problems in heat and mass transfer. So with respect to this, we have a problem here on isothermal evaporation of water into air. So this problem goes like an open pan 20 centimeters in diameter and 8 centimeter deep. It contains water at 25 degrees Celsius and is exposed to dry atmospheric air. If the rate of diffusion of water vapor is 8.54 into 10 power minus 4 kg per hour, estimate the diffusion coefficient of water in air. So we have an open pan here. So let me draw the open pan. So this will be the pan and it is filled with water. Not fully, partially. So we have this gap above the water, space above the water, which is x2 minus x1 given as 8 centimeters. So now the diameter of the pan is given as 20 centimeters. Pan is given as 20 centimeters. So 20 into 10 power minus 2 meters. So this is exposed to the dry atmospheric air here. So now let's write the given data. So D is 20 into 10 power minus 2 meters and the length or the depth of water inside the pan is x2 minus x1, which is 8 into 10 power minus 2 meters. The temperature of the water T is 25 degrees Celsius, which would be 298 kelvins. So the diffusion rate of water vapor is given as 8.54 into 10 power minus 4 kg per hour. So when you say diffusion rate, the diffusion of water vapor is nothing but the mass flow rate of water vapor into the atmosphere. So you have been asked to find out the diffusion coefficient of water, which is capital D. So now let's so we have to convert this into kg per second, which could be easily done by dividing this whole thing by 60 minutes and 60 seconds. So this gives you the answer in kg per second. So it works out to 10 power minus 7 kg per second. So now what you have to find? You have to find the diffusion coefficient of water in air. So A could be water, B is air. Now we know that the molar rate of water vapor is given as, this is available in the HMD data book, mass flow rate is equal to DAB divided by G into T P divided by x2 minus x1. I will come back to explaining all these coefficients. So natural logarithm of P minus PW2 P minus PW1. So A would be the area of the pan, which is the surface area. DAB is the one we have to find out. G is the universal gas constant, and T is the temperature, P is the total pressure, which is usually atmospheric pressure, and PW1 and PW2 are the partial pressures at the position 1 and 2. So this is position 1 and this is position 2. So now let's start solving this problem. So mass flow rate of A air is given as 2.37 into 10 power minus 7 is equal to, so this we arrived here, this is equal to, so DAB into A divided by GT into P by x2 minus x1, natural logarithm of P minus PW2 by P minus PW1. So we took the A here, so let us find this A. We can find the A here. A is equal to pi by 4 d square. The diameter is 20 into 10 power minus 2 square. So this works out to 0.0314 meter square. So now the value of G here, the value of G is constant. It is 8314 joule per kg mole Kelvin, and the total pressure P would be 1.013 bar. You see, it is given as 1 atmosphere. 1 atmosphere is 1.032 bar. So bar is not allowed to be substituted. It has to be converted to SI units. So 1 bar is 10 power 5 Newton per meter square. So this would be the total pressure. And x2 minus x1 it's already given in the problem. PW1. So PW1 is the partial pressure of water vapor at 25 degrees Celsius. So at this position at 25 degrees Celsius, we need to find the corresponding pressure in the steam tables. So from the steam tables, page number 2, at 25 degrees Celsius, the corresponding pressure is 0.03166 bar. So please convert this again to Newton per meter square. So the partial pressure at the top of the surface where we have dry atmospheric air with no water vapor, so the partial pressure of water vapor at that place will be 0 bars. So substitute it as 0. So now let's do the substitution. 2.37 into 10 power minus 7 into DAB into area is 0.0314 divided by 8314 into 298 multiplied by 1.013 into 10 power 5 divided by 0.08 into natural logarithm of 1.013 into 10 power 5 minus 0 divided by 1.013 into 10 power 5 minus 0.03166. So into 10 power 5. So now if you do the rearrangement, you get the diffusion coefficient as 2.58 into 10 power minus 5 meter square per second. So this would be the answer. Thank you.